This is going on page 102 when we're done. Okay. And before we get into what we're actually doing today, we're going to talk about a couple of other little identities here. So let's say I have sine theta times cosecant theta. Okay. And I want to simplify this. Well, I'm going to leave sine theta as sine theta. And then cosecant is the reciprocal of sine, so that'd be 1 over sine theta. And then if I put that over 1, that'll give me sine over sine, which is 1. So let's think about why that happens. How are sine and cosecant related? They are reciprocals of each other. And if I have 2/3 times 3/2, they multiply to give me 1. Reciprocals, when you multiply them together, they give you 1. So that should be no surprise, which means that if I have cosine theta times secant theta, those are reciprocals of each other, so it is 1. I don't have to do this middle step here. And then if I have tangent theta times cotangent theta, that's also going to equal 1. Again, you don't have to do that middle step. I mean, if you end up doing it or whatever, it's not the end of the world, but it is what it is. Okay, so on the stuff that we did last week when we were simplifying the trigonometric expressions using some of our identities, it told us things like make sure that you simplify to where you only have cosine of x in your answer and no other trig expressions. So that is kind of how your instructions will work on this. However, that is not what all this says here because I didn't go through and change it all. But let's talk about what this does say. We still need an end goal. So if we're going to simplify a trigonometric expression, what that means for us right now, we're going to rewrite it in an equivalent form as either a numerical expression, meaning maybe our answer is 1, or in terms of a single trigonometric function. Okay, identities are useful when we're doing this. And then we have some strategies. So we'll talk about these strategies as we go through some of them, but let's just go through them. Rewrite using reciprocal and quotient identities. That's what we did last week. Look for Pythagorean identities, okay, or possible ways to create one. Do I have something squared? Maybe I'm going to use those. I'm going to maybe combine fractions using a common denominator, or maybe break fractions apart, or maybe I need to factor. Okay, so let's look at this first one right here. We've got, so something disappeared from here. These should all have thetas in them. So secant theta minus sine theta times tangent theta. So these are not equations. There is no equal sign. I'm not solving for anything. I am simplifying. All right, so I've got secants and sines and tangents. So one of the strategies that doesn't really say this here, but well, it sort of does. It says rewrite using reciprocal and quotient identities, but I don't want to necessarily rewrite every single one of them. And sometimes you can hurt yourself by doing too much at once. But if I think, all right, I'm going to do that, and I'm going to put everything in terms of sine and cosine. So then I know that secant theta would be 1 over cosine theta minus, and then I'm going to leave sine theta. And then I'm going to multiply that by tangent would be sine over cosine. All right, so then over here, I can multiply that together. So that's going to give me 1 over cosine theta minus, then that would be sine squared, because sine times sine is sine squared, over cosine theta. I have two fractions. I have a common denominator. And so I can do 1 minus sine squared theta over cosine theta. All right, now I don't have a single trigonometric function, and it doesn't even tell me if it's supposed to be sine or cosine. We would be directly told that in a different situation. But I know that I have my Pythagorean identities. So I've got sine squared theta plus cosine squared theta equals 1. And I could write out all the rest, but I don't need to. I can see here that if I have, this says 1 minus sine squared. If I do 1 minus the sine squared, that's going to leave me with cosine squared. So this will give me cosine squared theta in the numerator. I'm just substituting over cosine theta. And think about what would happen if it was x squared over x. This is going to cancel out with one of those, and my answer is cosine theta. And I'm done. Okay. All right, let's look at number 2. So I've got sine, cosine, and tangent in here. So I think, again, I'll go with my quotient and make this into sine over cosine. So this is going to give me sine of A plus cosine of A times sine A over cosine A. So then these will cancel out right here. And I've got sine A plus sine A. And that's 2 of them. So that's going to give me 2 sine of A, which is not my double angle one that we talked about yesterday. Okie dokie. Now let's look at this next one. So I've got cotangent squared and cosecant squared. So that is also a Pythagorean identity. So let's think about how we come up with our other ones. If I can do sine squared plus cosine squared equals 1. Let's say I go through and I divide everything through by sine squared. That would leave me with 1 first here, plus, and then cosine divided by sine would be cotangent squared. And then this would be 1 over sine squared, which would be cosecant squared. And let's just go ahead and get the other one. If I divide everything through by cosine, sine squared divided by cosine is going to give me tangent squared theta plus 1, because I'm dividing by cosine squared, and 1 over cosine squared is going to give me secant squared. Okay, so there are my 3 basic ones. And if I substitute here, I can see that cosecant squared is 1 plus cotangent squared. So I can just substitute that right in there. So this is going to give me cotangent squared u minus, now I'm going to substitute something in with more than one term. So I need parentheses. Okay, just substituted that in for cosecant squared. Then when I distribute my negative, I'm going to get cotangent squared u minus 1 minus cotangent squared u. So these 2 zero out, and I'm left with a negative 1. Okay, let's look at number 4. I could change everything to sine and cosine. That would give me fraction and a fraction, which is not the end of the world because that's something that still we may not be able to avoid. But I don't necessarily want to distribute that sine x because I don't see that giving me anything with it is like it is. But if you look at this right here, I can rewrite this as sine x over cosine x times tangent x plus cotangent x. Okay, so basically I'm just kind of taking that fraction apart. And if I put all this over 1 and multiply this back, that's what I would get back. All right, so since this is in terms of tangent and cotangent, I can make this into tangent. Sine over cosine is tangent x. I'm going to multiply it by tangent x plus cotangent x. Now, I think I'll go ahead and distribute. When I do that, tangent times tangent is tangent squared. Tangent times cotangent, those are reciprocals, so I get plus 1. And then look at what this is. Tangent squared theta plus 1 equals secant squared. So this just gives me secant squared x. All right. Okie dokie. Next one. I've got cosecant theta minus this. Now, I could do reciprocals. Again, I'd get fractions and fractions, and I might just be spinning my wheels. But one of my strategies is to combine fractions, getting a common denominator. So when I look at number 5, I think it does help you to put this over 1 so that you can actually see them both as fractions. And then my common denominator will be cosecant theta. Cosecant theta, because that's what the denominator is there. In order for that to happen, and here, this one has to be multiplied by cosecant over cosecant. So that will give me cosecant squared theta minus cotangent squared theta. All right, all I did was get a common denominator, fractions. Then I've got cosecant squared minus cotangent squared. I look back up here. If I do cosecant squared minus cotangent squared, that means I'd move that over. That'll leave me with 1. So the numerator can become 1 over cosecant theta. And 1 over cosecant is sine. These are like little puzzles. Okay. All right, number 6. So I don't have, there's nothing squared, so I'm not doing Pythagorean identities. I could do reciprocals and stuff, but I don't know about all that. One of my other strategies, though, was to break fractions apart. And that's something that I don't think is always your first thought to do, because we don't do that a whole lot. We put a whole lot of fractions together. We don't always break them apart. So let's talk about what that means. If I have x over 2 plus y over 2, then I believe we could all agree that I have a common denominator. So that is x plus y over 2, right? We are used to going this way, right? Taking this, making it into that. But I can take this and break it apart into 2 fractions like that. So that's what I'm going to do over here. I'm going to break this apart into 2 fractions that both have a denominator of cosecant beta. Right? So this first one here is going to give me cosecant beta over cosecant beta, and then minus, and this will be sine beta over cosecant beta. Excuse me. All right, so cosecant over cosecant is 1. Sine and cosecant are reciprocals of each other. They multiply to give me 1. They do not divide out to give me 1. So I need to figure out what to do with my reciprocal here, and be careful, write it down, because it's so easy to get this stuff backwards and mixed up. My numerator is sine beta. Then this is the big fraction bar for my fraction. Cosecant is 1 over sine beta. All right? So then I have 1 minus, and I'm going to keep change flip. So I have sine beta times, I take the reciprocal of the denominator, and this will be sine beta over 1. So that's sine times sine. So that gives me 1 minus sine squared beta. And from my Pythagorean identity, if I look up here and I get 1 minus sine squared, that's going to leave me with cosine squared. All right. Again, little puzzles. All right, flip it over. All right, so I've got 2 fractions. I need to get a common denominator here. So my common denominator would be sine u times cosine u. So let's just write that down. We'll just write everything out here. So I'm going to multiply sine u times cosine u. So this fraction right here, to get my common denominator, I'd have to multiply it by cosine over cosine. So this is going to be secant u times cosine u, okay, because that's where it came down from there. This one has to be multiplied by sine over sine minus sine u times sine u. Now, could you have gone ahead and done sine squared? Yes, but I'm taking that and multiplying it by that. All right, keeping my common denominator, sine u, cosine u. Let's clean this up some. Secant squared, I'm sorry, not secant squared, secant times cosine, those are reciprocals. So when I multiply those 2 together, I get 1. minus sine times sine is sine squared u. Now here, at this step, I cannot simplify anything. I absolutely positively cannot cross out a sign with a sign because I got addition and subtraction there. But I know from my Pythagorean identity that we literally just did again, I'm going to leave my denominator, sine u, cosine u. 1 minus sine squared is the same as cosine squared. Now I can simplify, and I can cancel this cosine out with one of those. So that leaves me with cosine u over sine u. And we know that sine over cosine is tangent, so cosine over sine is cotangent. Okay, now number 8 has a double angle in it, stuff that we did yesterday. And you usually want to go ahead and get rid of the double angle. That if you have one, just take care of that one first. We'll leave cosine squared as it is for right now. So this is going to give me cosine squared theta minus. Now, cosine of 2 theta is more than one term, so I need to put it in parentheses. Okay, so however you're going to be able to remember them, whether you got to come up with it or what, but cosine of 2 theta looks like the Pythagorean identity, but it's a cosine, so it starts with cosine, and it's cosine squared theta minus, not plus because it's not the Pythagorean identity, sine squared theta. Okay, so all I did was substitute this in for cosine 2 theta because that's the identity. Then I'm going to have cosine squared minus cosine squared, that zeroes out. And then I have minus a negative sine squared, just leaves me with sine squared theta. Okay, number 9. Now remember, there are other ways I could rearrange cosine 2 theta, but just knowing that one, substitute that in and see what you can do with it. Like if you're not being forced to use one, use the one that you know. So I've got 2 double angles here. I'm going to take care of both of them. So in the numerator, I'm going to have 1 minus, so cosine 2 theta becomes cosine squared theta minus sine squared theta. And then sine of 2 theta is going to be 2 sine theta cosine theta. All right. So in the numerator, I am going to distribute my negative. So that's 1 minus cosine squared theta plus sine squared theta all over 2 sine theta cosine theta. All right, so I know that my Pythagorean identity is sine squared plus cosine squared or cosine squared plus sine squared. Even though I see cosine squared plus sine squared, this does not equal 1 because there's a negative right there. Okay, so really I could rewrite this as sine squared minus cosine squared. So that is not my Pythagorean identity. But I know from my Pythagorean identity, it's like if we needed to write it down, we'll write it down over here. Sine squared theta plus cosine squared theta equals 1. Okay, just so we have something to refer to here. That this 1 minus cosine, so 1 minus cosine squared is going to give me sine squared. So this 1 minus cosine squared, I'm going to replace that with sine squared theta plus sine squared theta, and that's all over 2 sine theta cosine theta. So then I have sine squared plus cosine squared, that gives me 2 of them, so 2 sine squared theta over 2 sine theta cosine theta. Now I can reduce. I can cancel those 2's out. I can cancel this sine out with one of those. And that leaves me with sine theta over cosine theta. And then I know that sine theta over cosine theta is tangent theta. And I'm done. Okay. You feel like I'm going way too fast on this? get it written down, go back and look at it, come back and watch the video again, whatever works for you. All right, now, number 10, there's a couple of different ways we could work this. So we're going to do it both ways. First of all, this looks like a sum or difference identity that we did. It starts with sine, so it's a sine one, okay? So it's sine of, and then we have alpha and beta, and we're going to figure out if it's plus or minus, because I do sine, cosine, cosine, sine. These two match here, these two match here. So the sine matches for sine, so since that's minus right there, okay? So that means then that this could just equal sine of pi halves, because that's alpha, minus the beta, which is really alpha right there, and I'm done. So that works, okay? Or, like over here, I don't know what theta is, and so I really can't do anything but simplify this like I did, but these have actual values in them that I could use. So another option would be, what is the sine of pi halves? Sine of pi halves is 1 times cosine alpha, minus the cosine of pi halves is 0 times sine alpha. So 1 times cosine is cosine, 0 times sine is 0, so here's another answer. And think about how the translations work, right? Sine is just cosine shifted over and vice versa, and that's what's happening there. So depending on whether it said you need to have just sine in the end or just cosine in the end, that's how you would decide which one it is. If it was multiple choice, again, just got to know that there's more than one way to do things there. Alrighty, number 11. So when I look at this one, I've got some squares, so maybe I want to do Pythagorean identities, but I also have tangent times sine. One of my options there was to factor. I've got 2 terms here. They both include a tangent squared, so I think I can factor that guy out. So let's do that. Tangent squared y. That leaves me with 1 minus sine squared y. All right. And then I know that this 1 minus sine squared is cosine squared. So this is tangent squared y times cosine squared y. And then I can write tangent as the quotient. I know tangent is sine squared over cosine. And I'm going to multiply that by cosine squared. Then I can cancel those out. Leaves me with sine squared y. And I'm done. All righty, last one. I've got 2 tangent theta and over 1 plus tangent squared. So if you look back at your Pythagorean identities, which we had written right here, 1 plus tangent squared is secant squared. And again, if you don't absolutely just know it, then you use this and you can get there, or maybe you know them, whatever works for you. You just got to be able to figure it out if you need it. All right, so I'm going to leave this as 2 tangent theta in the numerator. Denominator is going to become secant squared theta. All right, so now for me to get anywhere else, I'm going to need to do my quotient and reciprocals here. So this is the same as, I know tangent is sine over cosine, and that 2 is going to stay in the numerator. So this is going to be 2 sine theta over cosine theta. And this is my big fraction bar for my big fraction. Secant is 1 over cosine, so this will be 1 over cosine squared theta. Let me tell you what you can't do, all right? I can take the reciprocal of this and get this. I cannot take the reciprocal of the denominator right there because there's addition in there, so can't do that. So now I'm just going to keep, change, flip. I have 2 sine theta over cosine theta. I'm going to multiply that by this reciprocal, which is cosine squared theta over 1. Then I can cancel this cosine with one of those. And that leaves me with 2 sine theta cosine theta. And even if you don't know exactly what that is, hopefully by now at least you're like, ooh, that's something I've seen. I can't leave it like this because I have sine and cosine. Remember, it has to be a single one. But this is my double angle identity. This is sine of 2 theta. And there's my answer. Okay? And that's it. These take practice. Practice with your little half pink sheet. But remember, don't let that become a crutch because you are not going to get that on your exam.